So here we're going to try to find all the factors of 100. We'll do that both ways. So first I'll try listing all the factors. 1 is always a factor, and once you have 1 as a factor, you know that the number itself is a factor, so you get 1 times 100. Is 2 going to 100? Sure it does. 2 times 50 is 100, so we get that pair of factors. The next one would be 3. 3 does not go into 100 because these digits just add up to 1. Does 4 go into 100? Sure, we get 4 times 25. Does 5 go into 100? Yep, 5 times 20. So we get 5 and 20. 6, no. 7, no. 8, no. 9, no. And then 10, yes, 10 times 10. So 10 has no paired factor because it is its own pair. So, I don't know, we could put a little hat on it or something. 10 times 10 is 100. And if you're not, you may not be able to do all those in your head like I can because I've been practicing this for a long time, but just try it out, see if there's a remainder when you do the division. So all the factors of 100 will be 1, 2, 4, 5, 10, 20, 25, 50, and 100. So now if we try to do this using the other method, using the prime factorization, well, 100 is 10 times 10. And then split the 10s as 2 times 5, 2 times 5, and we're going to get 2 times 2, which is 2 squared, and then 5 times 5, which is 5 squared. So we get 2 2's and 2 5's. And so 2, 5, 5, 2. So now I'm going to build the chart. So now again, I'm going to start with 0 2's and 0 5's. So 2 to the 0 times 5 to the 0. It's 1 times 1, which is 1. And now we go through all the possibilities for the number 2. So 0, 1, 2. Now I don't go to 3 here because I've only got 2 2's inside of 100. So I have to stop at 2 2's in my chart because 100 is not divisible by 2 cubed, which is 8. So I stop at 2 2's, so 2 squared. And then when I do that, I reset the 2's back down to 0, and I increase the number of 5's to 1, and I go through all the possibilities of the number 2's again, keeping the number of 5's equal to 1. Now all the possibilities for the number of 2's are 0, 1, and 2, but now I still have a possibility of having more 5's, and so I reset the number of 2's back down to 0, and I increase the number of 5's again because I could have as many as 2 different 5's, and if I just do the 0's and 1's, I'll miss the factors that have 2 5's in them, like 25 and 50 and 100. And so we'll have 0, 1, 2, 2, 2, 2. So we keep the number of 5's the same, and again go through all the possibilities of the number of 2's. So turn these all into factors. 2 to the 0 times 2, 5 to the 0 is 1 times 1, which is 1. 2 to the first times 5 to the 0 is equal to 2 times 5, 2 times 1, which is 2. 2 squared times 5 to the 0 is 4 times 1, which is 4. 2 to the 0 times 5 to the 1. Well, that's going to be 1 times 5, which is 5. Now I'm going to have 2 to the 1 times 5 to the 1. Well, 2 times 5 is equal to 10. And then 2 squared is 4 times 5 to the 1 is 5. 4 times 5 is 20. 2 to the 0 times 5 squared. Well, 5 squared is 5 times 5, which is 25. 2 to the 0 is 1. 1 times 25 gives me 25. 2 to the 1 times 5 squared is equal to 2 times 25, which is 50. And then 2 squared times 5 squared is 4 times 25, which is 100, which should be the number I started with, and sure enough it is. One little thing, you might wonder how I always know how many rows to put in my chart. There's a little trick to that, which if you take a look at the number of copies of 2 and the number of copies of 5, so I've got 2 copies of 2 and I've got 2 copies of 5 here. If you add 1 to both of those, because I'm allowing the possibility of having none of those, as well as having 1 or 2 of them, so I have no 5's, I could have 1, I could have 2 5's, get 3 times 3 will give me 9 possibilities.